All right, in this lesson, we're going to look at what happens now when we have a charge that's moving. So our first and second hand rules were when we had a wire. So we had some sort of charges moving through a wire, and then we got a magnetic field going around it. Right? So we said that the magnetic field lines were circular, going around the moving current. Or if the current was round, then our magnetic field was in or out. So that was our first rule. That was our second hand rule. So now today what we're going to look at is what happens a little bit more in detail, and we're going to do a third hand rule. So if a current moving creates a magnetic field, then that means that there should be some sort of magnetic force. So if you have a charge or a wire or anything moving through a magnetic field, there's going to be some sort of force acting on it. So today what we're going to do is figure out which direction that force is and how to calculate it. So first thing, if we look at a wire in a magnetic field, so you can see in this first diagram we've got current running through the wire, and the second picture below it is just a two-dimensional view, so it might be a little bit easier to see. So you can see we've got our magnetic field, so we've got our B going to the right, and you can see that our current is going into the page. So now what we have to do is figure out how the force works. So we use your thumb still to indicate current, so our thumb would be going into the page. Our fingers point towards the B, and in this case our palm then would go upwards. So that palm is actually showing us the direction of our magnetic force. Or I'll show you in class using your three fingers. So you'd use your B to show the direction of the magnetic field, your thumb to measure the direction of current, B, your pointer finger would measure B, and then your F finger is your middle finger, and it makes sure all three of them are perpendicular to each other, and that'll be a good way to figure out the direction of the force. The formula that we use, there's two different formulas depending on the scenario. The first one is ILB, so that's if we have a wire, a certain length of wire in a magnetic field, so that's like the previous example, where I is our current, L is the length of wire, and B is our magnetic field, of course. And I also have a sine theta on here. So on your formula sheet, they don't write it as sine theta. They write it as ILB, and they say that it has to be perpendicular. So as long as it's perpendicular, that means it's 90 degrees. Sine of 90 would be 1, so it doesn't do anything different. The only reason we use the sine theta is sometimes, instead of it being perpendicular, maybe it's going to run at a bit of an angle. So if that angle is 60 degrees, the sine of that angle then would actually give us the perpendicular component. So it'll work either way, but most times you don't have to worry about the 90 degrees. So this first example, it's asking you to calculate the current in the wire with all of this. So this one we do have to use the angle because it's at an angle. So we would have, so our force is 1.887 newtons, and our current is what we're looking for. Our L is 3.45, our B is 1.29, and our angle is 67 degrees. So if we rearrange that equation, solve it for I, we will get 0.46 amps. So remember from before, current was just measuring how much charge is moving per second. Okay, so it's 0.46 amps. So now part B, it's asking, well, how much charge is that in 7.1 seconds? So off your formula sheet, there's a Q over T formula. So we put in 0.46 equals our charge, which is what we're looking for, divided by 7.1 seconds. We just multiply those, and we would get approximately 3.3 coulombs of charge. And then if we wanted to figure out how many electrons, we could still do that. We just divide it by 1.6 to the negative 19, and that would tell you how many electrons flow. So those two formulas are pretty easy, and they're just add-ons in most types of questions. So that was if we have a wire moving through a magnetic field, we get a force on it, but we also can use the same hand rule and just use a different formula if we just have a charge. So if we have a single charge, we use Q for the charge, V for the velocity instead of current, and we use B, magnetic field once again. And for the same reason, we have sine theta if need be, just because it could be at an angle, but most cases it won't be. So for this one, it says we're at perpendicular, so our sine of the angle would be 90, so we don't need to worry about it. So we just want to use QVB. So we have an alpha particle, so that charge would be 3.2 to the negative 19. Velocity is 1.22 to the 4. And our B was 23, so we just need to multiply all three of those together. And we get an answer of 9 to the negative 14 newtons. Okay, so pretty easy formula to work with either one, ILB or QVB. They both work, pretty much the same. And the key idea then is use your left hand for negative charges, right hand for positive charges to help you figure out the directions as well. And that's all.